This video is over lesson 40, area of a circle, and it's for my pre-algebra classes. In our previous lesson, we learned about the circumference of a circle. So now we're taking a look at the area of a circle. So if you would on your papers draw this circle, and let's make it 4 spaces big, that's going to make things easier for us. So if this is the circle, then going from the circle to the side would be the radius. In fact, going from the circle to anywhere on the side is a radius. Whether we're going right, left, up, or down. Those are all radii of this circle. Now, to give us a little more insight, a little more depth into the area of a circle, what I'd like you to do for me here is we're going to close this circle in a square. Before I look at the area of the circle, I want to look at the area of the square. So remember that the area of a square, the formula for the area of a square, is A equals S squared. So how long is this square? What's the side length of this square? Well, in order to go from here to there, you've got to move across a radius and then a second radius. So the side length of this square is 2r. It's r plus r, so 2r right there. It's 2r on this side. It's 2r on that side. It's 2r on that side. And so if we square that, well, 2r times 2r, 2 times 2 is 4, and r times r is r squared. So 4r squared. And that actually should make a lot of sense, because as we look at this, not only do we have a square here, but we actually have 4 smaller squares. And each of these smaller squares is a radius by a radius. So that means the area of these smaller squares is r times r, or r squared. So we have 1r squared, 2r squareds, 3r squareds, and 4r squareds. Now if we look at this though, the area of the circle takes up less space than the square does. So we know that the area of the circle is less than the area of the square. So at this point we know that the area of the circle is less than 4r squared. It's less than 4r squared. Now, how much less is the question? If you look at it, if we were to draw diagonals across this, you would see that the circle fills up most of that inside space, but there's a little sliver in each section more. So we know that it's more than half of the square. In fact, it ends up being a little over 3r squared. In fact, it ends up being exactly pi r squared. So pi, remember, is approximately 3.14. So the circle takes up a little bit more than 3/4 of the circle, of the square. And hopefully we can kind of visually see that. But if you've ever seen this formula before and you've been wondering why pi r squared, why that? Well, it ultimately comes down to thinking about a square being around the circle. So the takeaway of all this, though, is the formula. The area of a circle equals pi r squared. And at this point, go ahead and grab a color other than your yellow or your orange. I'm going to grab my blue, and let's just make that pop a little bit. I want that to stand out. There's our formula for the area of a circle. So let's try this out now. Let's say that we have a circle. There's my circle. And I mark this like that, as 5 inches, just like that. So one of the things we need to think through is, what is this measurement telling me? So I know that something is 5 inches, but what is that something? Well, center to the circle, that's the radius, which is perfect because the formula here uses the radius. That's what we want to know. So we're ready to go ahead and use our formula. Now, just as we did in the previous lesson, we have an exact value that we can find by leaving the irrational pi as a symbol. And then we have a rounded answer that we're more typically going to find, because that's a more helpful answer. And that's where we're going to typically use 3.14. So first of all, I am going to find the exact answer. So using the exact answer, I'm going just like the formula says. So a equals pi. I'm going to leave that as a symbol to make it exact. And then times r squared. So radius in this case is 5 inches. Now here's the thing. If I just say squared, exponents should only happen to whatever they're directly next to, which means that this should only be happening to the inches. Well, is the radius only inches? No, of course not. The radius is 5 inches. So we want that square to happen to the entire radius. So we have to put parentheses around that to say that it's all of that 5 inches that we're squaring. Now, you guys are growing up in a technological generation. It is quite possible that moving on into the future, that some of you are going to be working with technology where you may be programming things. And so this is something particularly you have to get comfortable with. You have to get used to, is those parentheses, because on paper, is it possible for you to make a mistake and not put the parentheses in, and then make a second mistake and not actually do what you had written, and the two mistakes can cancel? Yes, actually, it's possible. I would not give you full credit for that, but it is technically possible. But a computer, though, is going to do exactly what you've written. So if you don't put those parentheses in a computer program, you are actually going to get the wrong answer. So I want to train you right. All right, so let's finish this up then. So I'm going to take my 5 inches and square it. So 5 inches times 5 inches. Well, I still have pi here at the beginning. But then 5 times 5 will be 25, and then inches times inches will be square inches. Now remember our order. You can look back at the last lesson to see that order again. But remember, it's numeric constants, symbolic constants, variables, functions, units. So that means that my numeric 25 has to go first. My symbol pi has to go next. I don't have any variables. I don't have any functions. And then last is always the units. So the exact area of the circle is 25 pi square inches. Now, again, the only times that you're going to do this is when the book asks you to find the exact value, or if it says in terms of pi. That's the only time you're going to do this right here. All the rest of the times, we're actually going to replace pi with something more helpful. And typically, that's going to be 3.14 unless you're told otherwise. So I'm going to say that it's not perfectly equal to 3.14. It's approximately equal to 3.14. And then times our radius squared, just as we did before. And so this will be 3.14 times 25 inches. And now you'll notice that I switched to an equal sign here, and that is correct. That's not a mistake, that is correct, because when we look from here to there, the formula says that a equals pi r squared. Does the formula say a equals 3.14 r squared? No, it doesn't. So a is not perfectly equal to this. It's only approximately. But then when we look from here to here, are these things perfectly equal? Well, yeah, they are. 3.14 is 3.14. 5 inches squared does simplify to 25 square inches. So from this section to this section, they are perfectly equal. All right, and if we keep going then, finish it off, 3.14 times 25. You throw that in a calculator real quick, or you do some scratch work off to the side, 78.5 square inches. And so that is the rounded answer. Now, ladies and gentlemen, as you're working through your homework, this goes across the page a fair bit. So just to show you, if you want to do this more vertically instead of horizontally, all we're going to do is take that first line and we're going to move it vertically. So when we do things vertically, remember that we typically line up a new equal sign with an old one. So I'm basically going to take this section right here and now move it down here. But the trouble is, when I put in that new equal sign lined up with the old one, this empty space, we assume that whatever is above that empty space could fill this space. So we're assuming, even though we haven't written A, we're assuming that this would be A. Well, this section and this section and this section are all perfectly equal to each other. All three of these sections are only approximately equal to A. So when we line this up vertically, this actually will be an approximately equal to because we're lining it up with another approximately equal to. So 3.14 times that was 25 square inches. And then if we line it up again, 78.5 square inches for my answer. And I'm going to get rid of that little shadow of an A because I don't need it. So whether you do it horizontally, that's what it'll look like, or if you do it vertically, that's what it'll look like. Let's check out another example now. So new circle. This time I'm going to draw it like this. I'm going to label that as just 5. So if that's 5, there's something here that is just 5 units. We don't know what those units are. So later on, if we find out that they're centimeters, then we'll come in and we'll put centimeters on. If later on we find out that they're feet, we'll come in and we'll put feet on. So for right now, we just know it's 5. So, but 5 is what? What measurement is this that goes all the way across the circle through the center? Well, of course, that's the diameter. Now, the trouble with this, though, is the formula doesn't ask for diameter. So if you try to plug 5 in here for radius, 5 isn't the radius. So in this case, we need to find the radius. Remember that the diameter is twice as big as the radius. So if we just cut this in half, the radius must be 2.5 units. Now I could go with 2.5, but the fact that pi is approximately 3.14, I'd rather go with a decimal if I could to match that 3.14. Now we're ready to find our area. So the exact area would be pi times 2.5 squared. And now you'll notice that I didn't use parentheses this time because I also didn't write any units. So what is this exponent next to? 2.5, and 2.5 is the radius. We'll throw the word units on at the end, but I don't need them until the very end. So if we go ahead and simplify this now, this will be pi, and then 2.5 squared is 6.25. And then if we put this in the proper order now, 6.25 pi. And since I don't know what the units are, I'm going to put that placeholder in. Now, since it's an area, though, they'll be square units. So 6.25 pi square units. So if units are not given, then we don't have to write them in our work, but we will put a placeholder at the end in our answer. Whereas if units are given, then they should be a part of our work and a part of our answer. All right, now let's find the more helpful answer here. So A is approximately equal to 3.14 times 2.5 squared. So same thing, 3.14 times 6.25 if I square that. And now I would definitely grab my calculator and help me with that just to get it done quickly. So 3.14 times 6.25 comes out as 19.625. And then since we don't know what the units are, we put a little placeholder in there. square units because it's an area. And then from here, we're going to switch gears a little bit onto the back. And we have a vocab term called a sector. And since that is a vocab term, I am going to ask you to go ahead and highlight that in yellow. So a sector is a portion of a circle enclosed, so enclosed, surrounded by, so enclosed by two radii. If we have a circle, and I draw one radius, and I draw another radius, then this right here is a sector. That right there is a sector. And whenever we have a sector, we end up getting what's called a central angle. Now, central angle is another vocab term, but I'm not going to highlight in yellow because I want to color coordinate a little bit here. So, central angle is an angle formed by two radii. And for this one, let's grab our green, please. So if I have a radius and a radius, that angle there, formed by those two radii, would be the central angle. There's our central angle there. In this case, if I were to put some letters to this, let's say that where the radius hits the circle there is A, and where it hits is B. Let's call the center C for center. Then my central angle in this case would be angle ACB. So with those things there, we're going to go ahead and find the area of a sector. And this is just a slight expansion of what we just did. So before, area equaled pi r squared. But a sector is just a fraction of the circle. So we're going to put an F in here, and the F is going to stand for fraction. So what fraction of the circle is it? And I'm going to go ahead and use this example up here. Let's go ahead and call this, I know it's probably not drawn correctly, but that's okay because in geometry, we always go with what it's written as, not how it looks. Because sometimes things are drawn incorrectly, but we want to do the math correctly. So let's just call that 100 degrees. It actually looks like it's less than 90. It looks more like 80 to me, but we're going to pretend it's 100 because that's what I had planned. So sorry for the faulty drawing, but we're going to go with 100 degrees just to get the math done. So in this case then, I would say A is approximately equal to, we're not going to bother with the exact answer this time. We're just going to go with the rounded. So the fraction here, I'm going to use the fact that that central angle is 100 degrees. Because if it's 100 degrees, that's 100 degrees out of, well, how many degrees all the way around the circle? 360. So it's always going to be that number of degrees out of 360. And so then, if we move on, so that's my fraction, times pi, which we're going to make 3.14, and then times my radius squared. So in this case, let's go ahead and come back over here. Let's say the radius, let's label it as 8 centimeters. We're going to make the radius 8 centimeters. So then down here, remember that since we're squaring it, the 8 and the centimeters have to go in parentheses together so the whole thing gets squared. Now this is so big that I'm not going to have much space if I try to move to the right, so I'm going to work this one down. So first of all, I would cancel my degrees. Degrees on top would cancel with degrees on bottom. I'd probably reduce my fraction a bit. So 100 and 360 can both be reduced by 20. So 20 goes into 100 5 times, 20 goes into 360 18 times. So I have 5/18 is my fraction. That sector is taking up 5/18 of the fraction, so it has 5/18 of the area. Times my 3.14, and we got to do that exponent. So 8 centimeters squared would be 8 centimeters times 8 centimeters. 8 times 8 is 64. Centimeters times centimeters is square centimeters. From here, I would recommend that you grab your calculator and you just punch it in. So when you punch in your fraction, remember that fractions mean division. So punch this into your calculator. I'm going to grab mine and I'll show you what to do. So 5/18, I'm just going to do 5 divided by 18. And then I'm going to hit times 3.14. And then I'm going to hit times again and my 64. Hit equals. Now we get that big long number. It goes on and on and on. I am going to give you permission in these cases to go ahead and round off to the second decimal place, to the nearest hundredth. So just like 3.14 goes 2 decimal places, we're going to go 2 decimal places again. So I have 55 for a whole number. 8 is my first decimal place, but then 2 is my second decimal place. And we have to consider, since we're rounding this off, should this stay a 2 or should it round up to the 3? So remember, to figure that out, we always look at the next digit. The next digit tells us if that should go up or down. So 2 is little. 2 says, no, keep that down at the 2. So we're going to round this down. It's just going to stay at 2. And then the units, square centimeters, are going to stick around. Now that was the area of our yellow sector. So I'm going to ask you to grab your yellow and just put a box around that. Now I say that's the area of our yellow sector because now we're going to come back up here and I'm going to go this way. I'm going to use those same 2 radii, but I'm going to go the other way. This is also a sector. Okay. So just to emphasize the point, both the yellow and the orange are sectors of this circle. This orange sector is just going the other way around. So if we want to find the area of that sector, A would be approximately equal to, well, if it's 360 degrees all the way around, but 100 of it is in the yellow area, that means that 260 degrees must be in the orange sector. So that's 260 degrees out of the 360 total, times pi, which is 3.14, times your radius squared. Again, I would cancel my units there. Degrees and degrees will cancel. We can divide these both by 20 again. That'll be 13 though, and this will be 18, which should make a lot of sense because the 5/18 and the 13/18 together should make 18/18, the whole circle. So this then is approximately equal to 13/18 times 3.14 times 64 square centimeters. Once again, I would grab my calculator and just type it in. So 13 divided by 18, that's my 13/18, times the 3.14 times the 64, hit your enter, And so this time we end up with the whole number 145. Now for my decimal, the first decimal place is a 1, and then the second decimal place is that 3. So I want to know if this is going to round down and stay a 3, or is it going to round up and become a 4. So the 7, the first thing that's getting chopped off this, gets to tell me up or down. The 7 is a higher number, it tells me to round up. So that 3 will round up to a 4. And then we have our square centimeters. And that is our orange sector. Now, just a quick note, if we had been working this out horizontally, so this one right here, A is approximately equal to, I'm just going to do this small, so 260 degrees over 360 degrees. Those canceled, that became a 13, that became an 18, times 3.14 times 8 centimeters squared. Then this would have been perfectly equal to 13 over 18 times 3.14 times 64 square centimeters. And then at this point, remember that we rounded off. So if you are going to work this out horizontally, when you round off, we're going to have another approximately equal to 145.14 square centimeters. So every time we round off, we get another approximately equal to. So we get the first approximately equal to because A is only approximately equal to 3.14. There's a rounding right there. And then when we do this and we round it off, we get another approximately equal to. And that, ladies and gentlemen, is the end of our lesson.